Hi everyone. The topic that we are going to cover in this particular, you can say, tutorial is MergeSort algorithm. Okay ji. So MergeSort is, you can say, an algorithm that is basically used to perform sorting on data, any type of data. So before you can say having more insight of the MergeSort algorithm, first of all we should know uh, what is the type, this type of, you can say, algorithm, or what is the basically rule that it follows in order to basically sort a given particular data set. Okay, so this particular uh, merge sort algorithm works on a divide and conquer approach. That is, if I write it here, so it works on basically divide and conquer approach. So what is divide and conquer approach? That is, we basically divide a larger problem into a smaller problem, and when we have got various sub problems or the smaller versions of the larger problem, we basically solve them, and in the end we will combine or merge the solution of the sub problems into one big solution, and we will figure out the you can say main result or the outcome of the given problem. Since this is, you can say, divide and conquer approach, what it does is basically split the major or the large problem into smaller problems and solve it individually and separately, and then in the end combine all the result. Okay ji. Since this algorithm is a sorting algorithm, so we all first must be very careful or must have the insight of how this algorithm works. So for that, let's just consider few values. Let's say I am having 5, 4, 11, 2, 0, and let's say 10 as values of my array. Okay, so the size of this array is 1, 2, 3, 4, 5 and 6. That is, if I draw boundaries over here like this, so this boundaries represent basically an array, and all the indexes can be separated by these vertical lines. So here I have got 1, 2, 3, 4, 5 and 6 elements in this particular array, and the size of this array is 6, whereas index start from 0 and end at 5. So total size is 6. If I may write it like this, that I am having an array of size 6 and I want to sort this particular array. Okay, so in order to sort this, we have already seen certain algorithms such as bubble sort, but the runtime of bubble sort is big O of n square, which is very high. So we want an algorithm that basically gives us the optimized results in terms of the time complexity and space complexity as well. Okay, so how this algorithm work is, we cannot just directly jump into like shuffle or sort this array. We basically divide this larger problem into smaller sub problems. That is, at step number 1, what we do is we will basically you can say divide this 6 with 2. So what we get in the result? 3. That is, we will basically create an array of size 3 and an array of size 3. Two arrays of size 3, because 2 multiplied by 3 is equal to 6. I basically split or divide this array into two different parts. So here I have got an array of size, you can say 3, 1, 2 and 3, and here again I got an array of size 3, 1, 2 and 3. Okay, so I've got two different arrays of same size. Since it is size is divided by 2 is 3, so here I am also having 3 at this side and 3 at this side. So what I do is, after creating two arrays of equal size, and if I add this side, it will, like 3 plus 3, it will sum up to the 6. Okay, next part is I'll just rewrite the elements inside the cells, that is 2, 0 and 10. Okay, this basically completes my step number 1, and in next step I'll keep on repeating these steps again and again. That is, here what is the size? 3. So 3 divided by 2 is 1.5, and since we all know that 1.5 is not any number in terms of the index of an array, so we will like substitute it 1, and you can see since I have to divide a array into two parts. So one side would be having one element and the other side would be having two elements. Why? Because the size of this array is 3, and since 3 divided by 2 is 1.5 and I am considering it as a 1, so 3 minus 1 is 2. So I basically split this like this. Here I receive 4 and here the array would be having two elements as 4 and 11, and here its size is 1. Same goes for this type of structure. That is, if I may draw the lines, so it will come like this. This will be divided into this and this part. Similarly, or at this side I come up with the 2 and 0 and 10. So this part is also split into two parts. And now here you can see this is one element, its size is 1. I cannot further split it, so we will stop here. I don't split it again, but here the size is 2, so 2 divided by 1 is, you can say, size divided by 2 divided by 2 is 1. So I create an array of size 1 and another array of size 1. Similarly here I'll create an array of size 1 and another array of size 1. This 5 will remain as it is and this 2 will remain as it is. Okay, I'll draw the lines like this. Okay, so you have seen basically I have got a one big problem. I have split it into the, you can say, two every time I have splitted the big array into two different sub arrays, each of having size as size divided by 2, and here size refer to the parent array size. And every time I am splitting basically array into two halves, two equal halves almost. If the size is odd, then the, you can say, splitted array would be having one splitted array would be having one more size in the index. Okay ji, this basically at this particular point or at this particular level that I'll just draw a line for you like this. So this basically comprise or concludes our division part. Here we are just done with the division portion. We have divided the bigger problem or bigger array into the, you can say, sub problems or sub part, and until unless we reach at the, you can say, particular size where array size is 1, we stopped. So this is a larger problem. I have divided into smaller problem, and if I try to sort each and every array here at this particular you can say index or point, so 5 is array having one size. It cannot be further simplified or splitted or divided. So here 4 is also one size, 11 array having this element is also one size. So all of these you can say values at this index cannot be further, or arrays at that index cannot be further redivided. So this basically concludes the divide part. Now we will move towards the concur part. How concur work is basically, what we do is we basically try to create an array of size this plus this. So what we come up with 4 and 11, these two size, and we compare their values. Okay, so the array that we will that will be created here would be having size 1 plus 1 2, and the values we will compare these two values. Since 4 is a smaller value and 11 is a larger value, so it will come directly like this, and this 5 will appear just like this. Similarly, when we talk about this particular portion, here 2 will come directly like this, and here we will create an array of size 2, and we will basically compare these two elements. The smaller element will come first and the larger element will come later on. Okay, if I may write it like this, so I'll go for concur part like this. Okay, in next iteration what I do is I'll try to combine these two things, that is 1 plus 2, size 1 plus size 2. So the array that I'll come up with be of having size 3. Okay, and values, which value will come first? 5 will compare with 4, smaller value will become the part of this combined array, and 5 will compare with 11. Since 5 is smaller than 11, 5 will become part of this side and 11 will come as it is. Similarly, at this side, I also create an array of size, you can say 3. 2 will be compared with 0. 0 is a smaller value, 0 will come first. 2 will be compared with 10. 2 is a smaller value, 2 will come first. 2 will be compared with, then we will left with only one value, which is 10, and 10 will appear directly over here. Okay, this is how we are doing the merging part, or we are basically in the phase of conquering you can say this particular problem. Okay, in the end, you can see 3 plus 3 is 6, so we will create an array of size 6 and we'll start with comparison. We will compare first element with the first element of this array. So 4 or 0, which one is smaller value? 0. Okay, now we will compare 4 with the 2. 2 is smaller value. 4 will be compared with 10. 4 is a smaller value. 5 will be compared with 10. 5 is a smaller value. 11 will be compared with 10. 10 is a smaller value and 11 is left alone. So you can see here that this is my final, or you can say merged solution of the given problem. So basically you can see that all the tasks that I have shown in this blue ink are the phase where we divide this larger problem into the smaller problem, and then in the end we basically merge the smaller problems, sub problems, and try to figure out or create a, you can say create a solution which basically fits for the given bigger problem. We basically created solutions for smaller sub problems, then bit larger, then a bit larger problems, and in the end, in step by step, we have you can say figure out the solution or sorting of this particular algorithm. Okay, so now this was all about the demonstration of how MergeSort works, how MergeSort basically works on the strategy of divide and conquer approach. Next step would be is to create a, you can say, algorithm, or to work on this algorithm for in order to perform this type of MergeSort operation. Okay, so as we can see that all the operations above this green line are almost same, that is they are doing the splitting, dividing the array into two parts. And when we have encountered a particular scenario where we have array size as 1, we have like moved towards, you can say, combining the results. Okay, so here we have combined these sub problems and sorted it out and figured out the final solution of the given problem. So these are the, you can say, two different type of work being going on here. First work is divide and the second one is conquer. So in first work we basically divide an algorithm, and in second portion we basically merge it until unless we have encountered this particular condition, which we in case of recursive function call as a, you can say, base case or base function. Okay, so we will just quickly look at the you can say its algorithm, and then we will figure out the runtime of this particular MergeSort algorithm. Okay, so when we talk about the algorithm that governs all this procedure is, we come up with the two type of, you can say, codes. So number one is, you can say, MergeSort, and the second one is merge. Okay, so these are the two different functions that basically perform different tasks of strategies, or different strategies, different functionality. Number one is the divide approach. So this MergeSort here will cover the divide portion for us, and this merge will do the merging element, or combining these smaller problems into the or basically convert the smaller problems into the large problem. Okay, so what MergeSort will do is, let's say it is being given with an array A of a particular size. So at first step, as iteration number 1, what is it this algorithm do is that if it goes for the base case, checking of the base case, that is whether we have encountered an array of size 1 or not. So first comparison would be, if length of array A is equal to 1, then return. Okay, ji. So this basically performs the divide part, that is until or unless we encountered an array of length 1, you keep on performing other operations. If you have encountered an array having length 1, length any number greater than 1, so you need to perform some other operation that will come in the, you can say, else part. So in else section, what we do is we basically create two arrays of size, or basically we basically split this array into two parts. So the first one is, let's say I rename it as a q, and I do it like this, that I'm taking the lower value of the length of a overall divided by 2. So I'm taking the floor function here, so that if I encountered an array of size odd, that is 3, then in that case 3 divided by 2 and lower value will become 1. So array would become of size 1, and another array would become of size, you can say, 3 minus 1, 2. Okay, next step is I need to create arrays. So I'll just write it like this: create two arrays. This is basically my integer value that you can say specify here the value of basically size divided by 2, or the length of array divided by 2. Okay, now here I create two array. I'll name one as L, of having size 1 to Q, and another array of R having size Q plus 1 to, you can say, length of A. Okay ji. So here I have created, you can say, two arrays of having particular size. This is my line number 1. After creating you can say these arrays, next step is to do the copy. That is copy, let's say, the values of the original array A, values from 1 to, you can say, Q, to, let's say, L. Okay, so L, I have created this array over here. I have copied starting element, starting 1 to 2 Q element, or starting half portion, to this left side, left array, and again I have to perform the copy operation, which basically copies all the value of array from Q plus 1 to length of A into which array? R. This one. Okay, then this is how I have created two array. Now on each part of this array I have to you can say apply merge sort. That is, let's say I have created another ls, another result container, in which I am calling this function recursively, that is call merge sort on L, and at very next step I'll say call merge sort on right side, so that both of the arrays get sorted. In the end, when I have received this case, I have returned this function have returned. So my last step would be, I'll basically write it like this, that if this all of this thing has all of these lines have successfully returned, then go and call for the merge function, which basically perform merge on L of S and R of S. So you see, this is whole part of the division procedure, in which what we are doing is we are basically you can say we have array, we are getting or determining its size, and at next step we are creating two arrays and copying half portion to one, another half portion to one, and again recursively call this thing again and again until unless we have encountered the base case where the length of an array or a cell become 1. And when we have encountered such a case, we basically apply sorting on the divided or the divided sub you can say organized sub problems, or the you can say the problem that we have splattered into further sub problems. So this will basically merge this sub problem. Now here you can see that after performing, you can say, this type of operation, next step is to perform the merge operation. So when we talk about the merge operation basically do the functionality of combining the you can say final result or the output of the division procedure. That is basically it computes the solution of the various sub problems that are being, you can say, originated by dividing the original problem into different sub problems. So let's say I have been given here two arrays left and right. You can see L and R. I am being given with the, you can say, two here I'm being given with the two arrays L and R, and now I have to basically merge it. So the first step would be that I need to basically create array, or I have to basically allocate memory for an array. Let's say I call it as a B, and what would be its length? It would be like its size, it would be like length of L plus, you can say, length of R. Okay ji. So here I have like created an array having size twice of these two, or size that I have obtained here as a result of these two arrays that I have passed here. So in next step, let's say I have to basically compare each and every values of these two arrays together, that is whether the value contained in L is smaller or R is smaller. So for that I have to initialize two variables, that is I have to use I and initialize it 1, and at third step I'll use J, initialize it 1 again. Okay, so this is how basically I'm trying to, you can say, create flags in order to traverse each and every array. So now here next step would be, since I have to perform some operations again and again, so I basically allocate another, or assign or assume another variable, and the starting value in the for loop, and the starting value of this particular variable is 1, and the loop will terminate when we will reach at the point, you can say, where length achieve the value of P. Since in theoretically we start index with 1, so I'm writing here 1. If you are going to code it, so the starting value would become 0. Okay ji. And obviously to length minus 1, we will move to length minus 1. Okay, so now another important thing is we have to do the comparison, that is which value is greater or which value is small. So inside this for loop I'll write two, you can say, functions, two conditions. So the first one is if J is greater than length of right, I'm dedicating this J to R and I to L. So if J is greater than length, or, and second condition would be, or let's say this will fall here, I is less than equal to, you can say, length of L, that is the given first array, and okay, I'll put brackets over here, and the value L of I is less than equal to R of J. So this condition overall will basically do all the comparison function, and it also check here that whether these pointers are in limit or not, because if, you can say, I and J are not in the limit, or not in the, you can say, given you can say value, or the given range of the size, then our overall you can say array may or overall program may give array out of index, or this type of any exception. In other words, our program will fail. Okay, so after writing this code, what will come under this, you can say, if is what I do is I have to assign or insert some value in the array. So I'll write it directly like L of I if this condition is true, and then I'll increase an encounter, that is I equal to I plus 1. So this statement will make sure, or this condition will make sure, that the value of, you can say, left of array is greater than you can say is not greater than right subtree. You can see here the value contained in left array is less than or equal to the value contained in the right array. So that's why I have moved this I one step and J another step. Here, just for again for your reminder, this is basically for L array, and this J is the used as a, you can say, iterative integer or iterative counter for R array at the right side. Okay ji. So what if this condition false here, get false, that is what if L of R is greater than R of J, then in next line we will write else statement, and in else statement the code would be B of K should be assigned a value which is the value of the right side of, you can say, the given arrays, or the right side of the right array, basically the right array basically, and the counter that is dealing with the right array is J. And in 10th step again I need to move this J to the next index so that next time iterations can be performed more easily. Okay ji. And the last step would be to return this array B. So you have seen now that this merge sort is basically doing the division part, and this merge is basically combining the, you can say, final results into a, you can say, one particular array, into one particular final solution of final result. This is how basically MergeSort works, and this is basically the strategy of how MergeSort basically encounters or perform its functionality. Okay ji. Now another important thing that must be kept in your mind is, that is basically whether this particular algorithm is in order algorithm, or in place or out of place algorithm. Okay, this is very important question from any point of view. If you go for any academia interview, or if you go for an academia or if you go for even field work, like for programming or software development type of post, so basically they usually ask you whether this particular algorithm is in place or out of place algorithm, mostly in academia. So what is the difference between these two type of algorithms? Okay, so in place algorithms are those algorithms that are having you can say, that are basically performing all their work within a given memory set. That is, for example, if I am getting this array here, technically and ideally I should not be allocating extra memory, but here you can see that I am creating an array of size two different arrays of size 1 to q and q plus 1 to length of a. So here I am consuming exactly the same memory as that of array that has been passed to a given function. So basically this here I am allocating more memory than the allocated memory, or than the arguments that have been passed. Similarly in merge function you can see that I have been given with the two array subproblems, and I am creating a new array of length L plus R. So here you can see that I am having allocating memory again and again, and which is basically not initially given to me, or which is very different from the arrays that are being passed as an argument to these functions. So all those functions that requires extra memory in order to perform their work efficiently are known as out of place algorithms. On comparison to this, all those algorithms that basically don't require these type of extra creation of memories or allocation of memories are known as in place algorithm. So just look at this these whole two parts of the same merge sort function. So you can see that here we are allocating extra memory, so this algorithm is out of place algorithm. Okay, this algorithm is out of place algorithm. This is not an in place algorithm. Okay ji. So this till now we have seen merge sort algorithm and sorting using, you can say, merge sort algorithm, and how it basically uses divide and conquer approach. Okay ji. Next important thing is, what is the running time of the, you can say, merge sort algorithm. So when we talk about the runtime, so you can say runtime, we usually express it in the form of big O, and there is some value over here, plus there are three cases: best, average, and worst case. So whenever we you can say determine the time complexity of any algorithm, we basically look for these three cases: what would be the best case, what would be the average runtime complexity, and what would be the worst case complexity. So the best time, you can say best time complexity of merge sort is big O of n log of n. Similarly, for the average case, its complexity is big O of n log of n. And for worst case as well, its complexity is n log of n. Now you can see that here for each and every you can say cases, I have written here, you can say, same runtime complexity. There is no difference in the, you can say, runtime or execution time of merge sort for any of these cases. What would be the best case? Let's say array is given in already sorted order. Let's say and what would be the worst case that we could encounter when we talk about the merge sort is that we encountered an array that is having exactly the values that are in descending order, and average case is an array having randomly placed values in it. But in all these three cases, the overall runtime is big O of n log of n. So this sounds a bit, you can say, strange to us. So for that, let's go back towards this page where we have seen the working of merge sort algorithm. So here you can see that merge sort does not look at the values or the data set. At every single point, it basically splits the array into two parts. It doesn't matter whether this array is already sorted, it is in reverse order, or these values are randomly allocated. As you can see, these are randomly allocated values. In first portion, here above this green line, it does not look at the data set. No matter what the values may reside inside the array, you have to create an array and divide two arrays and divide into having the size exactly half of the given original array. At this step we did the same. This step we did the same. At every, you can see, at every step we perform the same type of operation without looking at the data. So this was the divide portion, and when we talk about the concur or merging portion, at this stage we basically look at the data, but we do the comparison. So no matter if this data is already sorted or not, we have to perform the comparison. We have to create an array of size L plus R. We have to create these arrays no matter what the data set may be. So the good thing about merge sort algorithm is it does not look at the data. So which type of you data may give to the merge sort algorithm, you always land with the big O of n log of n, since it is not dependent on the data. So your best time, worst time, and average case time complexity will remain same, that is big O of n log of n. Okay ji. This was the, you can say, general description about runtime algorithm. Till now we have seen what is merge sort algorithm, number one. Number two is how merge sort algorithm works and follows divide and concur approach. Number three, what is the, you can say, best time, average, and worst case time, computational time of the merge sort algorithm. And the number fourth thing is whether in merge sort algorithm is out of place or in place algorithm. So we have discussed four important things so far. Okay, so there is one more important thing left, and that is the representation of merge sort in the form of, you can say, recursive relation or recursion and mathematical equation. So in order to basically represent merge sort, the equation is actually the run timing or the time of the merge sort algorithm. Let's say t is a size that merge sort algorithm will require for n size of input. So its value is c, constant value 1, 2, or something if n is very small. If n is small, obviously if your input is small, input size is small, your algorithm will definitely work faster, and when performing the computation you may receive very minute or minor time. Okay, if n is not small, n is a large value, then what the equation of merge sort will become is 2t n by 2 plus d of n plus c of n otherwise. otherwise states here that n is greater value if n is not very small. Here what does this represents? This basically this thing, this one here basically represents that at every step what it does is MergeSort does is that it divides an array into two parts. This 2 represents that the original array is being divided into two parts, and this n by 2 represents that each part is of size original size of the array divided by 2. I repeat it again. T of n represents the computational time of MergeSort algorithm for input n of size n, okay, which is very small if n is small. Otherwise, what it does is if n is not small, it basically split the array, given array, into two parts, and each part is of having size n by 2. That is the size of main array or the original parent or given array divided by 2. As we are splitting the main problem into two subproblems. Okay, here T of n represents the cost of splitting or dividing the data. That is how much time we basically have to, you can say, we require in order to divide a data or in order to split our data into different parts. And this C of n basically represents the cost of merging the data back. Or you can say cost of combining the data. So from this equation we can apply different type of methods and strategy in order to get this time period that I have discussed over here. So from this particular equation of MergeSort we may get runtime that we have mentioned over here, that is big O of n log of n for best, average and worst case scenarios. Okay ji, if you can say we have this scenario where we are not like under the restriction or bound that memory is less. Ideally, let's say we have infinite memory and we basically want to perform an algorithm that is stable algorithm or that does not basically takes so much time for any type of data set. So we go for the MergeSort algorithm, because as we have seen in the code while doing the programming, we may consume more memory, but time wise we are consistent. We don't need much time for any type of data. Otherwise, there are some algorithms that are having best and worst case different as compared to the worst case, because they don't allocate extra memory. And we at this point we can say that we have studied one thing in data structures and algorithm course, that is there exists a trade-off between time and space or memory. So here you can say this thing is also satisfied. Here time is consistent, but memory consumption or utilization is, or you can say has increased. So if we want to go towards the optimization of space or memory, then definitely time will increase. We have to go or choose that scenario or situation where we can like somehow maintain the balance between these two factors. Okay, so this concludes today's lecture about MergeSort algorithm. If you still have any questions or queries, don't forget to write in the comment section. I'll answer you as soon as possible. Okay, so if you like this video, please press the like button and do subscribe my channel. Thank you for watching.